Okay, the Cambridge IGCSE chemistry exam is just around the corner, and I know that pressure is probably building. So let's use this time for one last super fast recap to make sure all that essential knowledge is locked in tight. Ready? Let's do this. Here's our game plan. We're going to fly through 5 key areas. We'll start with the absolute basics, the fundamentals of matter, and then build all the way up to some applied chemistry. Sticking to this structure will really help you connect the dots and get these concepts organized in your head for exam day.
All right, let's dive right into section 1, the fundamentals of matter. We have to start here with the basic building blocks to make sure our foundation is rock solid. So, what is everything around us really made of? Let's do a quick-fire review of the 3 states of matter. Solids, right? They have a fixed shape and volume because their particles are packed in super tight. Liquids have a fixed volume, but they take the shape of whatever container they're in because those particles can slide around. And then you've got gases, no fixed shape, no fixed volume. Their particles are just free to zoom around and fill any space. And that freedom of movement, that's exactly why gases diffuse so much faster than liquids. And of course, all this matter is made up of atoms. Just picture the structure in your head. You've got that central nucleus with positive protons and neutral neutrons, and then you have the negative electrons orbiting around in shells. Now, the most important thing to remember is that the proton number is everything. It's the element's atomic number. It's like its fingerprint. It's what gives it its unique identity. Okay, let's move on to section 2 and see how this all connects. Now we're going to look at how those atoms actually interact with each other through bonds, how they get rearranged in reactions, and, how we actually count them using this thing called the mole. At its heart, chemistry is really all about how atoms bond together. In metals, you've got this sea of electrons that can just flow freely, which is what makes them such great conductors. With covalent bonds, atoms share electrons to form molecules, like in H2O. And then there's ionic bonding, where one atom straight up transfers an electron to another. This creates charged ions that are really strongly attracted to each other, just like the sodium and chloride in your table salt. So how in the world do you count trillions upon trillions of atoms? Well, we don't. We use the mole. 1 mole of anything, whether it's atoms, molecules, whatever, is always this gigantic number, 6.02 times 10 to the 23rd particles. It's basically the chemist's version of a dozen, just a lot bigger.
Next up, electrolysis. This is all about using electricity to split up ionic compounds. So you pass a current through a melted or dissolved compound, and the ions get moving. It's all about opposites attract, right? The positive ions, the cations, they're drawn to the negative electrode, the cathode. And the negative ions, the anions, head over to the positive electrode, the anode. And to remember all of that, here are 2 of the absolute best mnemonics in chemistry. Seriously, don't forget these. Oil rig tells you that oxidation is loss of electrons, while reduction is gain. And panic helps you remember that positive is anode, negative is cathode. Trust me, these are lifesavers.
Moving on to section 3. This is where we get into the dynamics of change. We're going to look at the energy that drives reactions and the different factors that control how fast or how slow they actually happen. Here we have a classic comparison you absolutely need to know. Exothermic reactions release energy, so they make their surroundings warmer. Think about a campfire. Endothermic reactions do the opposite. They absorb energy, making their surroundings feel cold. This all means that in an exothermic reaction, the products end up with less energy than what you started with, while in an endothermic reaction, the products have more energy. So, what if we want to speed up a reaction? Well, it all comes down to collision theory. We need more collisions, and we need them to be more energetic. We can do this in 4 main ways. First, crank up the temperature. That gives particles more energy to move and collide harder. Or you can increase the concentration, or the surface area, which means there are just more particles packed in and available to collide. And finally, you can add a catalyst, which basically just gives the reaction an easier, faster pathway to follow. Now, some reactions can go both forwards and backwards. We call them reversible. When the speed of the forward reaction becomes exactly equal to the speed of the reverse reaction, we hit something called dynamic equilibrium. It might look like nothing's happening, but really, both reactions are still going at the exact same pace. It's perfectly balanced. And now it's time for section 4, a quick tour of your best friend in the chemistry exam, the periodic table. We're just going to focus on the key groups and the trends you need to know. This table is a perfect summary. Let's look at group 1, the alkali metals. As you go down the group, their reactivity increases. Why? Because that outer electron gets further from the nucleus and is way easier to lose. But for group 7, the halogens, it's the complete opposite. Reactivity decreases as you go down because it gets harder to attract that extra electron. And then you have group 8, the noble gases. They're totally inert or unreactive because they have full outer shells, which makes them super stable and happy as they are. All right, a quick rundown on metals. You know the basics. They're strong, they're malleable, they're amazing conductors of heat and electricity. But 2 really key ideas to remember are the reactivity series, which just tells us that a more reactive metal can kick a less reactive one out of its compound, and alloys. Alloys are just mixtures of metals that we design to be harder or more resistant to rust. And that brings us to our final section, Section 5. This is where we see all this chemistry in action out in the real world, with a focus on some organic and environmental topics. Here's your super fast guide to organic chemistry. Just remember, alkanes are saturated, meaning they only have single bonds. Alkenes are unsaturated because they have at least one carbon-carbon double bond, and that double bond is where all the action happens. Alcohols have that minus OH functional group, and carboxylic acids have the minus COOH functional group. Nail those down and you're in great shape. And finally, a little environmental chemistry. We use chemistry to make our water safe to drink, right? Through filtration and chlorination. But we also have to understand how pollutants like sulfur dioxide cause acid rain, and how greenhouse gases like carbon dioxide trap heat in the atmosphere and lead to climate change. Understanding the chemistry behind this stuff is so important. Phew, we have just covered a massive amount of ground, from the tiniest atom all the way up to global climate change. Hopefully, you can see now how all these different concepts actually link together. Okay, take a deep breath. You've done the work, you've revised, and you have the knowledge. You are ready for this exam. Just walk in there with confidence, because you've absolutely got this. Fundoo Tutor is a personalized learning platform that helps students succeed in Cambridge, IB, and other international curriculums with expert mentorship, structured learning support, and engaging resources.